Hey there. So in this video, what we're going to be looking at is we're going to be solving some quadratic equations. The method we're going to be using is factoring. So we're going to need to know how to factor in order to solve using this method. We're going to look through the process, so the steps of how to solve. We're going to look at 3 examples. Then we have an application question here we're going to look at, and then one more application question here at the end. So first things first, let's look at the process. So before we look at the process even, above that I just have some quadratic equations can be solved by factoring. So not all equations can be solved by factoring. If an equation isn't factorable, then you can't use this method. But if it is able to be factored, we can use these steps. So step A, we are going to write the equation in standard form. And standard form is this form, which I'm going to write. It's ax squared plus bx plus c equals 0. So basically you want everything on one side of the equation and you want nothing or 0 on the other side. Okay, step B, it says factor, so we're going to have to know how to factor. Then set each factor equal to 0 and solve to determine the value of the x-intercepts. Okay, and another word that we used for x-intercepts, we've used the word solutions, zeros, and we've also used the word roots. So all of these are synonyms, they all mean the same thing. Okay, so looking at our first example, so step A, write the equation in factored form. It is already in this factored form. We got equals 0 on one side, so equals 0 on the one side, so that's done. Then we're on to part B, so factor. So I can see by looking at these terms, each of them, the 2, the 4, and the 30, all of those are even, so I'm going to be able to pull a 2 out from all those terms. So let's do that. Pull a 2 out, and we're going to be left with this. Okay, then with this resulting piece, what we want to do is we want to take this inner piece and we want to factor that even further. So to do that, we're going to use our product and our sum. So the product is just taking the first number, which there's a hidden 1 in there, and multiplying by the last number. So 1 times negative 15, let's write that, 1 times negative 15, that just equals negative 15. Okay, and then the sum, that is whatever the middle coefficient is there, so positive 2. Okay, now with these two numbers, we want to find a product of 15, so the numbers are going to multiply to negative 15, and they're going to sum to give us 2. Okay, so you can think about the numbers. If you want to pause the video, you could do that. So the two numbers that we get are going to be 5 and negative 3. So when I multiply these two, 5 times negative 3 is negative 15, and when I add 5 plus negative 3, I get 2. Okay, so we got our two terms. Now because this is the simpler type where there's just that hidden 1 in front of the x squared, we can immediately break it down into these two terms that we just found. Okay, so what we're going to get is 2, an x plus 5 in brackets, and then an x minus 3 equals 0. Make sure you don't forget the equals 0. Okay, so these two terms that we just found, they just went into the brackets there. Okay, and then once we have that, the last part of our part B step was to factor these, which we just did, and then set them equal to 0 and solve to determine the solutions, zeros, or roots, or x-intercepts. So I'm going to take x plus 5, set this equal to 0, and then solve that equation. So to solve that, all I would do is minus 5 from both sides, So 5 and minus 5, those cancel, so that's gone. So I just have x on the left, and then 0 minus 5, that's just minus 5. So there's one solution. X equals -5. Our other solution, we take the other bracket, so I'm just going to do that over here. So x minus 3 equals 0. Then I will add a 3 onto both sides, and then we get x equals 3. So there's our solution for that one. Okay, so then if we wanted to check our answer, we could go to our calculator. So I'm just going to pull my calculator and go to y equals, and then I'm going to type in this left side of the equation. So clear what we had and put in 2x squared plus 4x minus 30. Okay, and then we can graph that. So I can see it has a x-intercept or a solution here, and it has a solution or x-intercept here. And to find those, we can go second, trace, and these are at a height of 0, so we want to choose that option number 2. Okay, and then you'll go to one of the points, so I'll just demonstrate this with the left point. Okay, so we want to get to the left side of that point. So left side of that would be going to the left, click enter, and then go to the right side of it, so click to the right. So now I'm to the right side of that point, click enter, and then click enter one more time to guess. And then we got -5. If I checked my other solution over here, doing the same process, I'm going to get that other answer that we had, which was 3. Okay, so we're done that one. Let's go on to the next one. So for the next one, we have 15 equals 8x squared minus 2x. So this one is not in standard form, so we need to move everything all onto one side. So let's do that. I'm going to move the 15, so I'm going to minus 15 from both sides. And that's going to give me 0 equals 8x squared minus 2x minus 15. Okay, and then we want to factor this. We're going to use the same method. We're going to use that product sum. So the product is taking the first number, 8, timesing by that last number, -15. And when we do that, you get -120. The sum is the middle number, so that's -2. So we're going to try to find two numbers. They're going to multiply to -120, and they're going to sum up to -2. If you wanted to pause the video to try to think of the numbers, you can do so. Okay, so those two numbers are -12 and 10. Okay, so once we have those two numbers, this one has an 8 in front, so it's a little bit tougher the way we factor it. I am going to factor it using a method called factor by grouping, and at the end of the video I'm going to do it another way where it's called the fraction method. Okay, so first we're going to do the factor by grouping method. So to do that, all you do is you break the middle term, this -2x, into a -12x and a plus 10x. So -12x plus 10x, and then we still have that -15 at the end. Okay, and the reason this is called factor by grouping is because I'm going to think of these two terms as a group. I'm going to factor them separately, and then I'm going to look at these two terms as a group, and I'll factor them separately. So looking at the first two, the only thing that I can pull out from both of those is a 4 and an x. So I'll pull out a 4 and an x, and when I do that, I'm going to be left with a 2x minus 3. Okay, looking at the next two, a 10x and a -15. The only thing they have common between them is a +5. Now, when you guys are factoring, whatever this term is, if this is positive, you want to pull out the same sign, so pull out positive. Okay, and then my leftovers in brackets, there's a 2x left over and a -3. And what you'll notice is that you have the exact same thing in brackets for both of these. Now that should happen. If it doesn't happen, that these are the same, you may have chosen the wrong two numbers up here. So you might want to go back and check those two numbers. Okay, now I'm just going to move this up a little bit so I got some more room here. Okay, so the next thing we do is, because these are the same, I can factor those out. So I factor out a 2x minus 3, because they both had one. And then the leftovers, the 4x and the plus 5, those go into our leftover brackets. Okay, and now we have it factored. So our last step, we just got to take each of these and set them to 0 and then solve. So let's do the first one. 2x minus 3 equals 0. So we're going to add a 3 onto both sides. Add 3, add 3. 3's cancel. And then I just have 2x equals 3. And then divide both sides by a 2. So divide by 2, divide by 2. So 2 divided by 2, those are gone. And then I just have x equals 3 over 2. So there is one solution. Then let's do the next one. So again, that was the 4x plus 5. So 4x plus 5, set this equal to 0. I'm going to subtract 5 from both sides. That'll give me 4x equals negative 5, and then divide both sides by 4. So I get x equals negative 5 over 4, and then box our answer. Okay, so those are our two solutions. Again, I could check those in my calculator if I wanted. The next one, we have m squared minus 16. So I can see it's already in the standard form. So everything is already on one side of the equation, and we got equals 0. Now this one, it looks a little different because there are only two terms. So whenever you have two terms, only two terms, one term here, second term here, and there is a minus in the middle, and both of these numbers are a perfect square, I'll write them as a perfect square so you can see it a little bit easier. 16 I could write as 4 squared. Whenever you can write it like that form, this is called a difference of squares, because it has a difference and there are two squares, an m squared and a 4 squared. So if it is of this type, to factor it, you just make two sets of brackets. Your variable was m, so that goes first in both the brackets, and then the number 4, that goes second in both of the brackets. So 4 and a 4. And then we put a plus and a minus. Okay, so that's just kind of the quick way to be able to factor this. Okay, so once we have that, then we just have to set each of these things equal to 0. So let's take m plus 4, set this equal to 0, subtract 4 from both sides, so m equals negative 4, and then do our other one over here. So m minus 4 equals 0, add 4 to both sides, get m equals 4. So there are our two solutions for this one. The next question we're looking at is an application question. So it says the zeros of a function are a half and negative 5, and the a value is 1. What is the equation of the function in factored form and standard form? So it's asking for kind of two different answers. So let's start with our factored form, and then we're going to fill this in with what we know. So our factored form is a times x minus r times x minus s. Okay, where this s and this r, all those are the zeros, or the x-intercepts. So it's the half and the negative 5. So let's just plug those in. And we can also plug in at the same time, we were told the value of a is 1, so we can put that into that spot right there. So it's going to be a 1. Then we had x minus, let's do the first one, a half. Then the second one, x minus, and then this one was negative 5. Okay, so x minus -5, those two negatives are just going to give us a plus. So let's write that out. So we got that. Now I don't have to write the 1 in front here anymore because 1 times anything is just going to be that thing. So I don't have to write the 1. If you wanted to keep the 1 there, you could keep the 1 there. Now one thing we want to make sure that we always do is we can't ever have fractions in here. So if you have fractions in there, I'll show you a trick to get rid of it. It's going to basically kind of move up in front of the x. Okay, so let's just write that on the side. So never have fractions or decimals in your factors. Okay, so just make a little note about that. We don't want to have that fraction right there. So the way we are going to get rid of that is this 2 is going to move up in front with the x there. So let's just write that. Okay, so that is our factored form answer. So factored form. In order to get to our next answer, to find our standard form, we need to FOIL this out. So we just need to multiply it all out. So let's do that here. So we have y equals, so we're going to have 2x times x, that's 2x squared. We're going to have 2x times 5, that's 10x. We're going to have negative 1 times x, that's negative 1x, or negative x. And we're going to have negative 1 times 5, that's just negative 5. Okay, and then these two terms, they're both x terms, I can group those and put those together. Okay, so that is our standard form. Standard form. So this is the last example we're going to look at. It's actually in your textbook on page 412. It's number 8. So it says a bus company charges $2 per ticket but wants to raise the price. The daily revenue that could be generated is modeled by the function, and then they give us this function right here. So r of x equals negative 40 times x minus 5 squared plus 25,000. It says where x is the number of 10-cent price increases and Rx is the revenue in dollars. What should the price of a ticket be if the bus company wants to collect a daily revenue of $21,000? Okay, so let's start by just rewriting out this function that they gave us. And then what we want to do is we wanted to make a daily revenue of $21,000. So our revenue is $21,000. And it said revenue was R. So in my equation down here, I'm going to change R to be $21,000. Now that we have that, there's two different ways that we could solve this. We could either solve it graphically or we could solve it algebraically. So for this case, we're just going to solve it graphically. So what we can do is in our calculator in y1, we're going to put the left side, so 21,000. And in our calculator in y2, we are going to put the right side of our equation. So once we have that, to solve it graphically, so let's just write this, to solve graphically, all we do is we find the intersection. So wherever these two graphs cross, the y1 and the y2, wherever they cross, that intersection point, that is going to be our solution. Okay, so let's graph this and see what it looks like. So I'm going to pull out my calculator. I'm going to go to my y1. I'm going to clear anything out of there, and then I'm going to put in that 21,000. Okay, and then click enter. And then for y2, we are going to put this in. Okay, now that we have those in, we can click graph, see what our picture is going to look like. Okay, now depending on what your previous window was in your calculator, you might have gotten the graph, but in this case I have nothing that showed up. Okay, so what I want to do is I want to play around with either my window or my zoom. So If I click zoom at the very bottom, oh, maybe not at the very bottom, zoom 0 though here, that is going to be a good option to pick. Okay, so zoom 0, I'll click on that, and what it's going to do is it's going to try to fit the screen so that it shows the important parts of the graph. Okay, so I can see it drew the one graph and then my second graph, and they cross right here, but this is going to be coming back down, and I'm thinking they're going to cross over here. So to see that, I'm just going to go zoom, and then option number 3, I'm going to zoom out. Make sure you click enter for it to actually zoom out. Okay, so I can see that one crossing point and then this other crossing point. So to find those, we're going to go second, calculate, and then we're going to choose intersect. That's going to find where the two graphs cross or intersect. Okay, all you have to do is be on the one curve. So if I scroll left and right, we can see we're on that straight line. Click enter. The second curve, we can see we're on the parabola. Okay, so we can click enter. And then what it's going to do is it's going to go from those 2 points, it's going to find the closest crossing or intersection point, which is going to be right there. So I'll click enter one more time, and then it gives me the solution. So when x is equal to -5. So let's write down that one answer. Okay, and then to find the other one, just repeat the process. Second, calc, intersect, option number 5. But now we got to move closer to the other point. Click enter. The other one is also closer to the point. Click enter. Enter to guess. Okay, and we get x equals 15. Okay, so now that we have our two answers of x equals -5 and x equals 15, we need to actually answer the question for what it asked. So I'll just get my calculator out of the way now. So it said, what should the price of a ticket be if we wanted to get this much money? So we got to figure out how much the ticket price is. Now these two answers that we got, these are not the ticket prices. They are only the values for x. Okay, and x was the number of 10-cent price increases. So I'm going to increase the price 15 times at 10 cents each time. And then the other one, -5, I'm going to actually do the opposite because it's a negative. I'm going to do, instead of increases, we will do decreases. So I'll do 10-cent price decreases. Okay, so let's do that down here. So for x equals -5, this is going to be -5 10-cent increases. Okay, so what that actually means is it's going to be 50-cent decrease. Okay, which in terms of dollars, that would be 0.50. Okay, so the price for this one, if we look back up at the top, it said it originally was going to be $2 per ticket. Okay, so it was originally $2 per ticket, but now we're going to have this 50-cent decrease. So subtract off 50 cents, and we get down to $1.50. Okay, so there's one answer for what the price of a ticket should be. Then we'll do for x equal to the 15. So that's going to be 15 10-cent increases. Okay, so if you have 15 10-cent increases, that is 150 cents, or that's just $1.50. Okay, so our price is going to be start at $2, and then it's going to increase $1.50. So increase $1.50. So our final price is $3.50. Okay, so our textbook questions that we're going to be working on for this homework is going to be on page 411, and we got numbers 1 and 2. And for these two, you're only doing the second column, so the second column of questions. Okay, so that's for number 1, it's just C and D. For number 2, it is E, F, G, and H. And then we are also doing questions 10 to 14. For number 13, you're just doing A and B. And a hint for number 12, turn the decimals into fractions first. So this second example we had done before we did the factor by grouping method. I'm now going to do it another way where it's just called the fraction method. Some of you guys might find this a little bit easier, so you can use this method if you'd like. So what I'm going to do is I'm just going to erase all of the stuff that we had before. This product and this sum though, this is still going to be the exact same step as what we did the first time we did it. So I'm just going to erase everything else except for that step there. Okay, so from before what we did was we changed it into that standard form. We did our product sum and we got our two numbers. So those will be the same steps with this. Next what we do though is we pretend like this is kind of the easier type where this 8 is actually just a 1 like we did up here, and then we were able to just break it down into the two factors. So we're still going to do that, but then there's an extra step after that. So it's going to be 0 equals x minus 12 and x plus 10. Okay, so once we have that, the next step what we do is whatever number was here, we are going to divide each of these two numbers, the negative 12 and the 10, by that leading term there. So I'm going to divide by 8, divide by 8. So now what we have are two fractions. What we want to do is we want to simplify these fractions. So 12 over 8, I could divide both of those by 4, so I'm going to get 3 over 2. And with 10 over 8, I can divide each of those by 2, so I'm going to get 5 over 4. Okay, then what I do is, if there is still a denominator down here, that number just moves up in front of the x, kind of like what we did down here to get rid of the fractions, it just moved up. It's the same idea up here. So this 2 will move up there, and that 4 will move up there. So let's do that. I'm just going to write it to the side here. Okay, and then if you compare this with what I had before, it is the exact same thing. All I have to do is take this, set it equal to 0, take this, set it equal to 0, and I get the exact same two answers as what we had the first way.